For 16 months, from 1970 to 1973, the Russians used a remote guidance system on Earth to operate two small rovers, which traveled nearly 31 miles over the surface of the Moon. This feat was one of the greatest technological achievements in the history of the USSR. Designed in utmost secrecy in Soviet laboratories and eclipsed by the triumphant success of the Apollo mission, the Lunokhod adventure remains virtually unknown to the public. The opening of the Soviet space archives and the work of the Spirit and Opportunity rovers on Mars have cast a new light on this tremendous odyssey. Here is the story of this mysterious lunar device and the adventure of the scientists who contributed to the conquest of the Moon. April 26, 1986, Soviet Union. The most serious nuclear accident of the 20th century strikes the Chernobyl nuclear power plant. After 3 months, thousands of men have received fatal doses of radiation. To save human lives, a strange automated bulldozer is clearing pieces of radioactive debris from the roof of reactor number 3. This remote-controlled science fiction device was designed under urgent conditions. To develop it, Moscow called on the engineers who 15 years earlier had driven the lunar rover on the Moon by remote control. The Soviet called their lunar rover the Lunokhod. For many years, its story remained secret.
I would say that most people, not just in the United States, but in the world, don't know of the Russian accomplishments on the Moon with the automated lunar sample return and the Lunokhods.
The Lunokhod, lunar vehicle in Russian, is a child of the 60s, the era when the USSR leaped into the competition with the United States in the race for space. This was a time when communism seemed triumphant, when the first satellite was called Sputnik, and the first man to orbit the Earth was named Gagarin. A period when the first cosmonaut to make a spacewalk was Soviet, when technology was the battleground of the Cold War. On May 25, 1961, President Kennedy told Americans that a U.S. astronaut would walk on the Moon before the end of the decade. Nikita Khrushchev immediately took up the challenge. The race for the Moon was on. The Kremlin told Sergei Korolev, a survivor of the gulags, to prepare the counterattack. This robust 50-year-old man was none other than the father of the Sputnik program, a scientist and a visionary. The Americans were focusing on a single goal, landing a man on the Moon. The Soviets had a secret goal, to send up an automated lunar vehicle device remote-controlled from Earth. For Sergei Korolev, this was the first step towards a dream, setting up a permanent base on the Moon. The future lunar rover was called Lunokhod. Korolev had to put together a team that could invent and construct this unprecedented device. He contacted the Red Army. The Transmash plant in Leningrad, which specialized in the construction of assault tanks, furnished everything he needed: space, technical know-how, and brains. The Transmash engineers were told to design the chassis for the future lunar rover. They participated in the Soviet Union's secret project, the conquest of space. A vehicle that could travel over the still unknown surface of the Moon, controlled in real time by a driver on Earth. Among these engineers, one man would soon become the soul of the program, Alexander Kamerjan.
My father was a tank designer by profession, and he first worked at Transmash as a specialist in heavy-tracked vehicles. He was later appointed Director of Research and Design for air cushion crafts. He began to acquire a reputation as someone who could conceive of and create the most unbelievable devices. My father brought together a team for the Lunokhod program.
For Alexander Kemerjian, the project to construct the Lunokhod was not a total shock, because with his capacities and technical expertise, he was a hard man to surprise. Nevertheless, he did look a bit taken aback.
For Alexander Kemerjian and his team of engineers, the Lunokhod program presented a series of unprecedented problems. How to design a remote-controlled vehicle operated from a distance of some 250,000 miles. How to predict its reactions in an atmosphere with 1/6 the gravitational pull of the Earth. In 1963, with computer technology in its infancy, this seemed to be an impossible challenge.
Major achievements of the Lunokhod program were, one, it was extremely early, two, that it did generate some meaningful science, three, that it represented the solution of some difficult engineering and design problems by some very smart people.
It's truly amazing. We, as tank designers, were given the mission to construct the Lunokhod lunar vehicle chassis.
Robotics was not yet a well-known science. For Alexander Kemerjian and his engineers at Transmash, everything had to be explored, invented, tested. No idea, even the wildest, was ruled out.
These people had designed a whole range of automated rovers for planetary exploration, and they have very clever mechanical designs and testing all of these concepts.
The first rover prototypes soon rolled out of the workshops. Their designers were the only ones who saw their wheels turn or saw them take their first steps.
We were put in a room closed off from prying eyes. This is where we set up our drawing boards. Access to our offices was forbidden. Our work was classified as a military secret.
There was never any talk about the Lunokhod at home. I only learned that my father had worked on the chassis for the lunar vehicle and that he was one of its designers after the device had reached the moon.
The Americans were making great progress. After the success of the Mercury and Gemini programs, their astronauts started intensive training. Kennedy on one side, Khrushchev on the other, put heavy pressure on their engineers. The upcoming geopolitical battle would play out in technology and in space.
We couldn't let the Americans have the moon. It was the Cold War.
But there was a problem. The moon was still a mystery. No one knew what its surface was made of. Was it hard or soft? Would the rover sink into it like quicksand? Faced with this enigma, Sergei Korolev consulted the best specialist in Soviet science, and then he announced his decision.
The surface of the moon is hard. It was not possible to design a remote-controlled lunar vehicle able to travel over a terrain of dust, sand, and rock. We had to find a single option and make a decision.
Once this decision was made, we started thinking about the first prototypes. And later, when we saw samples of the lunar surface, we knew that Korolev's decision was correct.
Thanks to Korolev's bold decision, the Lunokhod program could move into the mechanical research phase. Another decision immediately arose. Should the rover have tracks or wheels? Once again, the engineers turned to Korolev.
Korolev told us, "I won't give you any advice. You're the specialist, you figure it out."
Alexander Kemerjian and his tank designers initially favored a track drive mechanism. But was this really the right solution?
I quickly understood that it would be extremely difficult to use tracks because the electrical energy required to operate the motors was only around 300 watts. Can you imagine? It's the energy of a light bulb. It's very, very weak. The energy of a light bulb was supposed to power the Lunokhod under the extreme conditions on the moon.
Plus, if the tracks got stuck, it would be the end. With several wheels, it could continue on unimpeded.
The Lunokhod chassis took shape under the care of the Leningrad engineers. Here are the Rover's wheels, as large as a car's, just under 8 inches wide and 20 inches high. The tread, which had to grip the lunar surface, was a mesh fitted with crampons. And yet another puzzle. The vehicle had to weigh under 242 pounds. More discussions, more theories, more tests, and a new discovery with a titanium aluminum alloy classified as military secret.
For us, creating a mechanical device that could travel over a specific surface wasn't really a problem. The difficulty was in creating a device that met all the technical requirements.
Their mechanical devices were extremely clever, and so they had a much more of a classical engineer's approach to it. Try it, build it, see it, test it, doesn't work, try it again, do it this way, and if we only get 75%, that's okay. Next time we'll get 95%, and then the time after that we'll finally have full success. They were much more willing to have a systematic, ongoing approach.
In 1964, just 2 years after the initial sketches, the Transmash engineers were able to test their first prototype. Equipped with 4 drive wheels, their strange robot turtle took its first ride with a periscope camera.
We placed a Japanese video camera on it and controlled the machine from a distance using a television. We then started thinking about the remote control guidance system.
The engineers then had to anticipate the rover's reactions on the moon. For this, Transmash created a secret hangar known as the Drome. From a cart, 2 engineers controlled the second-generation prototype on a lunar track riddled with obstacles. The device had 8 drive wheels with independent suspension. It only required 3 to remain operational. Alexander Kamerjan was faced with a new problem, this one purely mechanical. In the atmosphere, when 2 metal parts are in contact, a film of oxide forms at the friction points, acting as a lubricant. In a vacuum, the 2 parts would mold together. The answer? They designed a new fluoridated oil, which did not evaporate in a vacuum. The electrical motors were encased in hermetic boxes. But a major step remained: to test these inventions in a gravity-free environment.
Sergei Korolyov offered to launch a satellite just for us, so that we could test our engine compartments and the mechanics in a gravity-free environment. In the end, we didn't need a specific satellite because we found room in an existing satellite already scheduled to launch.
After checking this technical step in space, the Lunokhod was ready for full-scale tests. In utmost secrecy, the Transmash engineers transported their prototype to Kamchatka Peninsula, 9 time zones away from Leningrad and Moscow. Why wouldn't the volcanic landscape in the far eastern region of Russia be similar to the surface of the moon? This experiment was an opportunity to test the automated control systems for the first time. This penetrometer, for example, which would measure the density of the lunar surface.
It was not an absolute replica of the lunar surface, What were important were the characteristics of this surface, its capacity to detect the reactions of the motors and chassis. This surface corresponded to these requirements, and this was the most important thing.
In 1965, Sergei Korolev delegated the entire production of the Lunokhod to the Moscow-based Lavashkin Institute, which specialized in space probes. Executive Director Georgy Babakin supervised the design of the lunar landing module. The Lunokhod, a strange rolling tub, was equipped with electronic and scientific equipment. From Moscow, Georgy Babakin could then issue specific instructions concerning the development of the chassis and the autonomy of the motors assembled in Leningrad.
Babakin's group sent these instructions. Make sure the Lunokhod goes down the ramp to the lunar surface and drives at least a few meters. Everyone will then be grateful to you. But we also knew that if the Lunokhod only drove a few dozen meters and stopped, we wouldn't be spared.
At Cape Canaveral, the Americans had conducted multiple launches to finalize Saturn V and the Apollo spacecraft. They worked methodically, never deviating from the single goal set by Kennedy. The Soviet scientists were dispersed. Their hopes for landing a man on the moon rested with a giant N-1 rocket. But with each launch, this hope never lasted more than 50 seconds. This was the mid-60s. The USSR was still in the running for moon race. But for how long? In January 1966, Sergei Korolev died during a routine surgery. The USSR gave a national funeral to the man who masterminded the country's first successes in space. Korolev is buried at the base of the Kremlin. With him, the Soviets buried many of their hopes for reaching the lunar surface before the Americans. Georgy Babakin had to rebuild the confidence of his team. The Lunokhod tests started up again in full force. They were now conducted in Moscow and Leningrad, often 24 hours a day.
We fixed up the offices so that we could sleep there. We brought in mattresses, sheets, blankets, and called that part of the plant the Charmash Hotel, because we usually manufactured chars, which means tanks, hence the Charmash Hotel.
A new device appeared on the Lunokhod, a lid the inventors nicknamed the frying pan, which had a solar panel on the underside. This was a crucial invention. During the 2 weeks of the lunar day, the unfolded lid would provide energy to the drive wheels and to the instruments inside the compartment. During the 2 weeks of the lunar night, the lid would close to protect the rover from the cold. But with temperatures of minus 275 degrees Fahrenheit, no one could be certain it would be enough.
Lunokhod designed itself the thermal control system with the radioactive heater and the lid that shuts and opens, which also serves as a solar collector during the day. That thermal design was very ingenious.
A polonium-210 radioactive power source, which powered a generator, was fitted to the back of the Lunokhod. During the lunar night, the heat shield closed and the generator heated the gas contained in the insulated and pressurized compartment.
It looked like a big wash tub on wheels. Anyhow, that thermal control system was pretty neat.
To withstand the temperatures of the lunar day, which could reach 320 degrees Fahrenheit, the Lunokhod was protected by a ventilation system. A gas circulated in the compartment when the electrical equipment generated too much heat. The heat was then discharged outside via a thermal exchange unit. At each stage, Babakin's group ran meticulous tests on these innovations. Very soon, the small rover would be ready to drive on the moon. But the program still needed to find men who could drive it from a distance of 250,000 miles. Once again, the program directors turned to the Red Army. By late 1966, 45 officers had been selected secretly. After a series of tests, only 14 candidates were selected. They were stunned to learn that their mission was to drive a lunar rover. Vyacheslav Dogvan, filmed here in 1967, was one of the 14 pilots. He recalls this experience, which marked him for life.
Before us, they had tried to use aviators, tractor drivers, car drivers, and even cyclists. They selected men who know how to assess a situation rapidly and who could memorize and reproduce this situation immediately.
The future drivers underwent intense training in the Drome at the Simferopol Space Command Center in Crimea. They learned how to control the vehicle using a joystick. Focused on the monitors, the officers repeated the maneuvers they would perform once the rover reached the moon, over and over again. Clearing an obstacle, climbing out of a hole, anticipating, turning right, moving forward, turning left, backing up, emergency stops.
The Lunodrome was only 200 meters away. We could have seen it, but the curtains were closed. This is why all the information came through the control screen, exactly as if it were happening on the moon.
There was a 30-second lapse between a command issued on Earth and its execution on the moon. For these men, this time lag was the most difficult problem to overcome in learning how to control the vehicle.
The vehicle operator had the greatest responsibility during the control of this vehicle. He could be nervous about making a mistake, but obviously this was not always the case. Everything was fine if you had correctly analyzed the situation, the various parameters, and taken the right decision. Things should have been perfect, but then suddenly you fall into a hole. In this case, either the joystick malfunctioned or the motor stopped on its own, and then you think you did something wrong.
Vyacheslav Dogvan and his colleagues were well aware of the importance of their mission. In this battle engaged with the United States, the destiny of the USSR was in their hands. And in a country where the fear of the Gulag still existed, the anxiety of failure was palpable. In November 1968, a pilot crew was ready. But a decisive round was playing out on the other side of the Atlantic. December 21st, 1968, the Saturn V rocket was carrying 3 American astronauts aboard. For the first time, in the Apollo 8 capsule, men were orbiting the moon. On their side, the Soviets managed to place 2 probes on the surface of the coveted goal. The success of Luna 9 and Luna 13 provided a wealth of extraordinary photographs and crucial information about the lunar surface. But with the repeated failures of the N-1 rocket, Russia no longer had any hopes of reaching the moon before the Americans. 2 men could still save the honor of the Soviets: Georgy Babakhin, Alexander Kemurjan in their secret box, the Lunokhod. Babakhin's group was putting the final touches on the rover in Moscow. There were no more problems with the compartment's resilience and the separation of the elements from the lunar landing platform. All the scientific instruments were installed and the components operated perfectly in a void. The ramps leading down from the landing platform were operational. The helical and whip antenna, which received electromagnetic waves, responded to more than 200 commands for controlling the rover. The Lunokhod, which was carried in the hold of a rocket, was the size of a small car, 1,666 pounds, just over 7 feet long, 5 feet wide. But it was a strange car indeed that could drive in the void of empty space operated from the Earth. At that time, even the Americans thought that such a technological exploit was impossible. In early 1969, the small rover was fitted into its landing module. Then both were finally placed in the upper section of the Proton rocket. The Lunokhod was ready. After a decade of feverish preparations, the race to Moon was closing in on the final sprint. On February 19, 1969, the Proton rocket was launched from the Baikonur Cosmodrome with the Lunokhod aboard. Success for the Russians was within reach. That day, more than a rocket went up in smoke, more than a lunar rover prototype. It was the hopes fueled by a decade of hard work. The Soviet engineers had to undergo a final ordeal. Watch the American triumph.
4, 3, 2, 1.
On that unforgettable day of July 21st, 1969, Neil Armstrong dedicated the American victory on the Moon to all of mankind. The entire world was astonished by the footsteps on the lunar surface. But in Moscow and Leningrad, scientists knew that history would record another milestone, the mark of the lunar rover wheels. For Alexander Kamerjan, there would be no respite for an entire year. On November 10, 1970, the Soviet pilots and technicians were huddled in the control room at the Simferopol Space Center. Several thousand miles away, in Baikonur, the countdown had begun. At 3:44 p.m., the Proton rocket took off. A new Lunokhod was aboard. At an altitude of 50 miles, the Proton rocket reached the speed required to orbit the Earth. After several engine thrusts, it launched the Luna 17 spacecraft, which gradually climbed free of the Earth's gravitational pull. It took 4.5 days to travel the distance from the Earth to the Moon.
The entire program was secret. Only the estimated lunar landing date wasn't, because many astronomers were awaiting this event in observatories. But as soon as the Lunokhod landed on the Moon, the secret behind the project was fully revealed.
The lunar landing site had been carefully selected. After orbiting the Moon for 48 hours, Lunokhod 1 started its historic descent. On November 17, 1970, Luna 17 made a soft landing in the Sea of Rains and settled on the lunar surface at a 4-degree angle.
I experienced this moment as an amazing burst of emotion. When the landing platform touched down on the Moon, it was tremendous.
The flight engineer shouted, "The Lunokhod has landed on the surface of the Earth." He quickly corrected himself, "The Moon." Everyone burst into applause.
The landing ramp was deployed. The lunar surface stretched ahead of the Lunokhod wheels. But who would make the final decision to start up the lunar rover and drive it down these few feet? The team, over its initial excitement, had to analyze the parameters concerning the vertical and horizontal position of the Lunokhod to avoid any possibility of a fall as it rolled down the platform. 3 hours went by. The first images of the surface had reached the Simferopol command post on Earth. The entire team was utterly focused. The tension was rising.
Suddenly, Genya Latipov announced, "I see the moon's surface. It's flat. The surface is flat." And then he added, "And it's beautiful."
The images show that the Lunokhod was correctly positioned for its descent. There were no obstacles on the lunar surface in front of the titanium and aluminum wheels. The order to proceed was given.
At that exact moment, Genya Latipov, who was controlling the vehicle, had a pulse of 140. Genya had never reacted like that before.
Responding to orders transmitted through 250,000 miles of empty space, the Lunokhod descended to the surface. 16 months after Niels Armstrong's historic step, this was a moment of triumph for the Soviet engineers.
The Lunokhod descended to the surface, then moved forward 15 to 30 feet. Then it stopped. We could make out the marks left on the lunar surface. It was fantastic. A fairy tale.
In Leningrad, Alexander Kamerjan had just undergone serious surgery. One of the fathers of the small rover followed its first steps from his hospital bed.
I was in the room with Kamerjan, and my eyes filled with tears. It was a total triumph. We'd put so much energy into it. Personally, I'd not taken a vacation in 3 years.
The Simferopol Space Center in Crimea gave the order to deploy the helical antenna and open the lid of the solar panel. There were no Soviet cosmonauts on the moon, but instead a small, perfectly crafted rover which responded to orders from the distant USSR. Radio Moscow broadcasted the Internationale. For Leonid Brezhnev and the Kremlin leaders, this success brought hopes for a revival. Would the Lunokhod bolster support for the Communist Party? Not so sure. The international press praised the rover's success, but the applause was above all for the genius of the Russian scientists and engineers.
It was a unique vehicle. The Americans hadn't even thought of it. If we had launched it a little bit earlier, maybe we would have felt somewhat better, but that wasn't the point.
Doing automated rovers on the surface were done by Lunokhods in the early 1970s, was not repeated again until the US finally did it in 1996, 97 with the Mars Pathfinder.
Celebrations were underway across all 11 time zones of the Soviet Union. At Simferopol, the stress level among the drivers was intense. Riveted to their screens, they had to solve any unexpected pitfalls on the lunar surface. After 65 feet, the first disappointment was severe. The guidance cameras were placed too low. The drivers had a view of a person crawling on all fours. It was impossible to clearly see stones or craters. The partially short-sighted Lunokhod moved forward another 33 feet. The team panicked. It had disappeared into a crater. The temperature inside the Lunokhod rose dangerously high. They had to cut off the power supply quickly. This was not the planned procedure, but they didn't want to take the risk of losing the vehicle.
We decided to cut off all the safety mechanisms, to turn the Lunokhod more to the left, level out the motor, close the lid of the solar panel, and back out of the crater.
The Lunokhod responded perfectly to the radio controls from Simferopol. It shifted into reverse, and the extraterrestrial cybernetic animal obeyed the pilot's commands. Every 9 hours, Dogvan and his colleagues took shifts controlling the Lunokhod, following its hesitant movements on their displays. They operated the joystick, forward, reverse, stop, rotate, 2 turning angles, 10 and 20 degrees, two possible speeds, 1/2 mile and 1.24 miles per hour. A concentrate of mechanical and electronic intelligence. It was a miracle of dexterity. Dogvan and his colleagues had to constantly anticipate the commands to be transmitted, as the vehicle was being piloted under difficult technical conditions. A fixed image from the moon was displayed line by line and only remained visible for 10 seconds before it was replaced by the following one.
The operator of the directional antenna had a crucial role, as he had to make sure that the antenna was always pointed at a specific reception zone on Earth.
Lunokhod incorporated multiple scientific innovations. Equipped with a spectrometer, an X-ray telescope, and cosmic ray detectors, it transmitted a host of valuable information to Earth. A ninth free wheel measured the distances traveled. With its penetrometer, the vehicle could measure the density of the lunar soil, just as cosmonauts would have done. After a few days, the rover had almost established a lunar routine. Then suddenly, a crisis. Lunokhod had fallen into a crater.
For some unknown reason, Genya gave an order to stop the vehicle. But he shifted from second gear to first gear. The Lunokhod continued forward. He thought it would get through the crater without any problem.
Поворот направо 60 градусов.
The team shifted to crisis mode. The steep walls surprised the driver with a temperature of 266 degrees Fahrenheit. The wheels slipped. The men were exhausted. After 9 long hours of risky maneuvers, the rover they believed was lost finally made its way free. After 14 Earth days, the rover shut down to hibernate and withstand temperatures of minus 274 degrees Fahrenheit during the 2-week-long lunar night.
As soon as the lunar night arrived, we all took a good steam bath. After we started processing and analyzing all the data recorded in the logbook, we didn't budge until the scientific and technical reports were finished.
Lunokhod, initially scheduled by its designers to run for 90 days, continued for nearly 11 months, traveling nearly 7 miles. It successfully accomplished all the planned scientific tasks and transmitted more than 20,000 images of the lunar surface, 500 tests and complete analysis of soil samples. This was the greatest achievement in Soviet astronautics.
The chassis could have operated for a longer time, but the nuclear resources for heating the internal components of the Lunokhod were used up. The Lunokhod stopped functioning. As my father used to say, it simply died a natural death.
Awarded the Order of Lenin for the success of the Lunokhod, Alexander Kamerjan remained an unknown figure in the West. But beyond the Iron Curtain, this success had not surprised French researchers who had been working with the Soviet space program for several years. By late 1972, the Lavochkin Institute had constructed a second Lunokhod. The new vehicle carried more scientific equipment than its predecessor. The navigation cameras were mounted higher for a better view of the lunar surface. The primary goals of this mission was to determine, using a French-made laser corner reflector, the distance between the moon and the Earth to within 3 meters.
A joint experiment was conducted by Soviet and French specialists. Laser ranging devices were installed on the large telescope in the Crimea Astrophysics Observatory, which is important for the study of the Earth's structure.
January 1973, a new success for the USSR. Luna 21 soft-landed in the Sea of Serenity with its payload, Lunokhod 2. The aim of the Franco-Russian laser-ranging measurements was to help predict volcanic activity and earthquakes and to study continental drift. On May 9, 1973, Lunokhod 2 set a new record, traveling 23 miles. Then, after 4 months, it stopped, like the earlier model, and shut down for eternity. By operating 2 rovers on the moon, the Soviet engineers did better than avoiding a humiliating defeat for their country at the hands of the United States. They produced a success which was rehashed by Soviet propaganda for years. Yet, these men remained in the shadows for a very long time, until history finally remembered them.
Everything was absolutely secret. All the preparation and all the documentation concerning the construction was secret. Who accomplished all this work in the Soviet Union? It was all totally concealed. Who was Korolyov? We only found out the day after his death. Who was Babakin? Everyone only knew the day after he too died. That was life in the USSR. It was the Cold War.
For more than 10 years, Alexander Kemmerjan had been one of this secret program's masterminds. But the experience of this brilliant man and of his team of engineers would not remain unknown. Chernobyl, spring of 1986. Would Moscow be able to handle the catastrophe after the explosion of reactor number 4? The USSR sent its firemen, helicopter pilots, soldiers, and laborers into the ruins of the power plant. These men, known as liquidators, risked their lives, wearing inadequate protective aprons to clear away the highly radioactive debris. In the rubble of Chernobyl, the authorities had to stop an uncontrollable nuclear reaction and clean the contaminated surfaces. Leaders in the Kremlin remembered the small remote-controlled rover. Kemmerjan was summoned urgently to Moscow. He was given 3 months to construct a remote-controlled vehicle that could clear the deadly debris projected by the explosion onto the roof of reactor number 3. The goal, to save human lives.
Alexander Kemmerjan attended a meeting with many managers from companies linked to national defense. They absolutely had to find solutions. As soon as he returned, he asked us, how can we help them? What can we do?
After the tremendous technological success of the Lunokhod rovers, Kemmerjan and his colleagues had not stopped their work. They continued to develop and manufacture all sorts of robots intended for use on more distant planets. With this amazing expertise, the Transmash team was able to develop a new version of the Lunokhod, a miniature vehicle called STR-1.
We started working much more intensely than we had for the Lunokhod, as the time constraints were much shorter. We had never seen anything like it. Once the STR-1 was designed, within a week, it was almost completely built. The metal chassis of the STR-1 was right there in front of us.
The STR-1 was a fully automated titanium bulldozer. The notched wheels were cut from solid blocks of metal alloy so that it could travel over the broken tar roof of the power plant. As with the Lunokhod, a test track scattered with debris was constructed to test the bulldozer, equipped with a special remote-control guidance system. In early July, the STR-1 was ready to be shipped to its final destination, Chernobyl. On July 15th, a helicopter lowered the vehicle to the still intact roof of reactor number 3. In this urgent race against the clock, Transmash did not have time to provide special training to drivers.
Kemmerjan brought us all together and said, friends, we are the only ones who know the STR-1. To pilot it, we'll have to go ourselves. This situation was extremely complex. Certain components were not yet fully operational. We didn't know how the machine would actually function.
Despite the deadly risks, a first team of Transmash engineers, led by Pavel Sologub, operated the vehicle throughout the entire month of August. Mikhail Malenkov led the second team and spent 30 days on the contaminated roof.
I agreed to go enthusiastically. I understood where I was going. I took risks, but I knew what to do and where we could or couldn't go, and what was feasible or not.
The SDR-1 functioned efficiently, but ran into guidance problems due to the extremely high levels of radiation. Kemerjan's robots saved many human lives, although very few people today know who constructed this strange arrival at Chernobyl. In 1986, the name Kemerjan was unknown. Readers of Western scientific magazines had been, to say the least, surprised by articles by three astronautical geniuses, Alexandrov, Leonovich, Yuglov. But who knew that they were written by the same person, Alexander Kemerjan? After the collapse of the Soviet Union, the West finally learned the real name of the man who ran the development program for the chassis of many planetocods, in Russian, vehicles that travel on planets. In 1990, the chassis for a Marsocod designed to operate on the Red Planet started to intrigue Western scientists. As the Americans and Europeans started planning their future rover missions to Mars, they became interested in the Soviet expertise.
As soon as the Iron Curtain came down, we were able to communicate with foreign colleagues. Thanks especially to Alexander Kemerjan, we began to work with American specialists for the first time and started working very closely with the French.
The Russians had this very good rover program, and we met the groups that were working on them. We learned that these were the people who had actually done the only planetary rover to date, which was the Lunokhod.
The most important thing for us was to conserve the expertise and knowledge acquired by our elders.
1992. The people at the Jet Propulsion Laboratory of Pasadena in California discovered the mysterious Alexander Kemerjan. The Americans invited him, along with a few Russian engineers, to their test center in Death Valley. These images were unimaginable during the 40 years of the Cold War. Kemerjan, a hero of the Soviet Union, walking serenely on American soil. Even though everything wasn't perfect, the former enemies joined forces to test the Marsocod rover, invented in Leningrad 15 years earlier in the utmost secrecy. The vehicle drove easily over the slopes of the dune the Pasadena researchers called the Martian Hill.
It's wonderful. And so there is where the Marsocod that they brought demonstrated that it was completely bulletproof as a machine you could take out in the desert. No matter how dirty it got or anything else, you just turn it on, it works.
They in turn invited us to Kamchatka to test the rovers, and we did worldwide publicity with these tests. And I think that had a large role in inspiring American scientists and engineers to begin thinking about the role of rovers in our Mars program here in the United States.
At the age of 70, Alexander Kemerjan finally received recognition in the international scientific community. In addition to his activities at Transmash and his membership in the International Institute of Spatial Robotics, he was promoted as a first-class scientist at the Russian Academy of Cosmonautics of Tsiolkovsky.
The Americans were extremely respectful of the scientific work we accomplished in our country at Transmash and the Lavochkin Institute. My father felt the Planetary Society was very important. He and Louis Friedman were very good friends.
And I'll never forget walking with Alexander Kermazan on the side of a volcanic mountain that was so hot that if you stood still, it burnt a hole in your shoe. So you had to keep moving. And here's Kermazan in his 70s, lightly going up the sides of the mountains, and we're having trouble keeping up with him. It was a remarkable experience.
Everyone is capable of doing extraordinary things, each in his own way. Some are perfectly happy doing simple things in good spirits. Others, however, concentrate on details. We're all different, and it really doesn't matter if you focus on space travel or work in the fields. What's important is to do what you really want.
Alexander Kermazan died on February 24, 2003 in St. Petersburg. He left as a legacy 2 small rovers on the surface of the moon, carrying the red flag of a former empire. In the future, men and automated vehicles may travel together to distant worlds. They will owe a debt to Alexander Kermazan, Georgy Babakhin, and to all the Russian engineers who were the first to design a way to operate a vehicle on another planet.